Hello friends, this question is from the test series number 10. Subject name is analog and topic name is DC biasing. It's a 2 marks problem. In a problem we have one common emitter circuit with potential divider bias or self bias, and question says that the current gain of the circuit is 100 or beta is 100. Beta is 100 as a given, and the question says that the VBE base 2 meter voltage is 0.7 volt, and we need to neglect the collector reverse saturation current. ICU has to be neglected, and question says that find out the value of R1 and R3 if collector to emitter voltage VCE is 2.5 volt. So if VCE is 2.5 volt, we need to find out the value of R1 and R3, right? Where R1 is the resistor from supply to base and R3 is a resistor from supply to collector terminal. These two resistors we need to find it out. You can see that question has already given the value of collector current. We know that IC is approximately equal to the IE, so I can assume that my I is also equal to the 1 milliamp. The next thing is that we know the emitter to ground resistor R4, which is 300 ohm, so I can find out the value of my emitter terminal voltage of my emitter terminal VE. It should be equal to 300 into IE, which is 1 milliamp. So VE is nothing but 0.3 volt. So my VE is equal to the 0.3 volt. So my voltage drop across R3, if I need to find out, so voltage drop across R3 is 5 and voltage of VC. So we already know what is the value of VCE, which is given as a 2.5 by the circuit, and VCE is nothing but VC minus VE. This is equal to 2.5. So if I need to find out the value of VC, it should be equal to the 2.5 plus VE, which is 0.3, which we have just calculated. So it means that my VC is equal to 2.8 volt. So if you can look at the diagram, I know the VC, I know the supply frequency, supply voltage, so I know the voltage across R3, I know the current across R3, so I can easily calculate the value of R3 using Ohm's law. So my R3 is equal to 5 minus 2.8 upon 1 milliamp, which is comes out as 2.2 kilo ohms. So we have calculated our R3, which is 2.2 kilo ohm. Next thing we know that our base to emitter voltage is 0.7, right? Similarly, my VBE is 0.7. VBE is basically VB minus VE is 0.7. We know the VE, which is 0.3. It means that my VB will be equal to 0.7 plus 0.3, which is 1 volt. So my VB is 1 volt. If my VB is 1 volt, so VB is my this voltage across base terminal, which is 1 volt. So current across 10 ohm will be, so current across 10 ohm will be equal to the 1 divided by 10 ohm, which is equal to the 0.1 ampere, or I can say that 100 milliampere, which is a current across 10 ohm resistor. So we know we have already neglected the base current, so it means that this current across 10 ohm resistor will be equal to the current across R1. We already know the V1, what is the VB, we know the supply voltage 5 volt, so we also know the voltage difference across R1. So my R1 will be equal to the 5 minus VB by 100 milliampere, which is 5 minus 1 by 100 milliampere, which makes it R1 is equal to the 4 upon 100 into 1000, 100 cancel, which is across 40 ohms. Means that value of R1 is 40 ohms, value of R3 is 2.2 kilo ohm. So my correct option is option A. A is my correct option. Thank you.